Okay, so we've seen that these operations, addition and multiplication, they may or may not be defined depending on the size of the matrices that are being input into that operation. So in this video, I want to just do a quick little conceptual check as far as whether we understand when matrix operations are and are not defined. So let's consider the following question. We've got matrix A over here, and I'd like to determine whether addition with these other matrices is defined. So for example, can I add matrix A to B? And so when I say addition with A defined, that I mean adding it on to A. And recall with addition, it only is defined if the matrices have the same size. So I can't add matrix A with matrix B because they're different sized. I can't add matrix A with matrix C because these are different sized matrices. I can't add A and D. The only matrix that I can add A to would be matrix E. So in this first example, we can add A and E, but that's about it. No other matrices would work when I try and add them with A. Same idea with the other one. So for B, I can add any matrix that has the same size as B with B. So that would mean not A, not C, not D, not E, but I can add F to that. So we can add B and F. That would be a defined operation. For matrix C, out of these options, there is no matrix that I could add to C because all of these matrices are different sized from C. And for that record, if we were thinking about what could we add to matrix D, none of these matrices could be added with D because this is 3 by 3 and none of the other matrices are 3 by 3. When it comes to multiplication, recall we want to make sure that if we're multiplying A times B, that A, which might be M times M, and B, which is N times B. It only makes sense if the number of columns of A is equal to the number of rows of the second matrix B. So let's just write out the sizes of each of these matrices. Matrix A has 3 rows and 2 columns. This is matrix B is a square 2 by 2 matrix. Matrix C has 2 rows and 3 columns. D is a square 3 by 3 matrix. E is a 3 by 2 matrix. It has 3 rows and 2 columns. And lastly, matrix F is a square 2 by 2 matrix. So if I want to consider which matrices am I able to multiply by A, well, let's look at A. So A has 2 columns, so what we're going to need is any matrix that has 2 rows is going to work. So I need to have the same number of rows in that matrix as our first matrix has columns. So that would mean matrix B is okay because that has 2. Matrix C would work. Not matrix D, not matrix E, but matrix F would work. So these operations A, B, A, C, A, F, these are all defined products. However, we can't just invert these orders. So here I'm paying attention to the order that things are multiplied. So if I start with A, the only matrices that I can then multiply A by would, in this example, be B, C, and F. For matrix B is a 2 by 2 matrix. So any other matrix B has 2 columns, any matrix that has 2 rows is going to work. So that would not be matrix A, but B times C, that is a defined operation. And the only other matrix that we could multiply with B would be F. All the other matrices have 3 rows, so they're not going to be able to be multiplied by matrix B. Matrix C has 3 columns. So now here's matrix C, and it has 3 columns. So the only matrix that I can multiply by would be a matrix that has 3 rows. So that would be matrix A, for example, would work. Not matrix B. We could multiply C times D, and we could also multiply matrix C by matrix E, because matrix E has 3 rows and matrix E has 3 rows. So we need to pay attention to the matrix size. It's a little bit easier to identify when addition works because we need them to be the same exact size. Multiplication, we just need to be really careful that the first matrix has the same number of columns as the second matrix has rows.